This is the third of three methods for solving the traveling salesman problem. So here's, again, traveling salesman problem premise. You start somewhere, you have to go to every city and then return to where you started, and you're trying to find the cheapest way to do it. And there were three methods. Here's the third. First one was brute force. That's where you list every possibility. It takes a while. Even for a computer, if it's a large enough vertex edge graph. Nearest neighbor, that's where you find the nearest one, or shortest or cheapest, however you want to word it, and you go from there and then find the next shortest one, and then eventually you're just going to have no options left, and you go, like in this case, to Chicago and then back to Atlanta. And here is the cheapest link algorithm. And with this, it requires us to make a list of all the edges, or their weights of the edges, in this case the dollar amounts for airfare, and we're going to put them in order, and we're going to see as we go through which ones we can and cannot use as we go from smallest to biggest. And again, this is not going to, it's kind of like the nearest neighbor, it's not going to necessarily always give us the cheapest, but it does give us one that is one of the cheaper ones. So what we're going to do is list all of these edges in order from smallest to greatest. So the smallest one is 149, and I left a little gap here because I want to list what it is. That's AD. And then the next biggest one is, you look at it and you're looking, oh, 151, and that would be Buffalo to Chicago, or Chicago to Buffalo. And then the next one is looking, 185, and that would be Atlanta and Chicago. And the next one is 199, and that is Atlanta and Buffalo. And the next one is 258, and that is BD. And the last one is the biggie, and that's 271, and that is CD. All right, I'm going to grab a highlighter, and what I'm going to do is try to just go through here and complete a circuit going from lowest to highest. All right, so here we go. I'm going to complete a circuit that begins and ends at A. So I'm going to just go ahead and highlight the first one for reasons that will become obvious later. So 149, that one's definitely in. Okay, why would it not be in? Just trust me, it's in. All right, we'll deal with that in a minute. The second one is also in. We're always going to highlight the first two. Why is that? Well, I'll tell you in a minute. Okay, now if you're like, oh, these aren't connected, who cares? You're good. Then we're going to get to the third one. When we get to the third one, we do need to really start considering what we can and cannot do. I can highlight AC, and the reason I can is because it does not hinder me from completing the circuit prematurely. Let me give you an example. I'm going to grab a Post-it note here. Pardon my squeaky stool if you hear it. Let's suppose that I have a D, and here's B, and here's C, and C. Let's suppose the first one I highlighted, let's disregard this for a moment. The first one I highlighted was here, and the second one I highlighted was here. Then if the third one on my list would have been this, can't do it. I can't do it because if I do this, then how are you ever going to get to Buffalo, right? It's just not going to work. You can't do it. So you don't need to complete your circuit prematurely. So in this case, 185, we're good. Like, I can connect A and C, and we're okay. So there we go. That one's good. And now I'm going to keep going. And then 199. As I look at 199, I think, okay, so am I ever going to be completing a circuit and completing it, I guess, prematurely? And if I was to do the 199 here, then I would have a triangle here and then this random other place over there. And I can't. Like, you'd go Atlanta, Chicago, Buffalo, back to Atlanta, and then Denver. That's not a circuit. So 199 is not an option. That's not going to work for you. And we go to BD. BD. If I was to connect Buffalo and Denver, oh, that would work. See, if I connect this, then I will be able to go and back. All right, so 258 is an option. That may not have been the best explanation, but that's the best one I have at the moment. So as we go through, I'm going to give some more hints about what we do and what we don't do. So let's just jump to the next problem. And we're going to have shortest to longest, 3, 4, 5, 6, 7, and 8. That was easy. And we'll put the sides listed with that. So the 3 is AB, and the 4 is BD, and the 5 is AC, the 6 is CD, The 7 is BC. 8 is AD. All right, fantastic. So I'm going to throw in a few more hints as we go through this one. AB is in. Oh, you know what? We didn't finish the last problem. Oh, well. We'll come back to it in a minute. So 3 is in. There we go. There's 3. That is the shortest. Now, technically on our graph, it is the longest based on what we see visually, but we're going with the number, not with the actual length of the segment. All right. Then the next one. We'll highlight that. I always highlight the first 2. Here's why. It's time I got into an explanation now. Okay. If I'm going to complete a circuit that begins and ends, well, anywhere here, I'm going to go with A, but if I begin and end anywhere, then I'm going to go to and from every city. At this point, I've already gone to B and away from B. You will never, ever, ever go to B again. You've gone to B and away from B. So the degree, the highlighted degree of every vertex should be 2. Now, the degree technically is 3, but the ones I've highlighted, it's just 2. I will never go to B again. BC is out. BC is not a segment that I will use. Because if I did, I'd be going to B and away from B and then somehow back to B. And what? No, you can't. That's just not going to work. All right? So that is the reason, actually, that you always use the first 2. Because when you use the first 2, you're never going to have a degree higher than 2. Like I used to be here, I used to be here, and then I'm good. But I'll never, if I use the first 2, which I always do, I never go above a degree of 2. All right, let's get to AC. Oh, by the way, here's what you can't do. Don't do AD, because you'd have a triangle. I don't want a triangle. I want to connect all 4, right? And I'd be connecting 3 of them, and I'd never go to C, right? So I need AC. AC is going to work. So we're going to highlight that one. Okay, now here's what I like to do. You don't have to do this every time, but I like to. So what I'm going to do is look at this and say, well, you know what? I have a degree of 2 on B, so I'll mark out all the B's. I have a degree of 2 on A now, a highlighted degree of 2. I'm going to mark out those. That really does narrow it down, and it was kind of obvious anyway. So if I'm going to start at A, I could go here. I got to go to C. There it is. You have no choice at this point but to do this one. So it did actually happen to be the shortest 4. And so final answer that I did not do for the first problem, and I'm about to do now, would be A, B, D, C, and then back to A. Now, if you list this in reverse order, that's okay. You could go A, C, D, B, A. That's cool. And I'll add those up. And when I do, I have 18. $18, 18 miles. We don't know what it really represents. Let's go back and finish number 1. My bad. So Atlanta to, and it doesn't matter if you go Denver first or Chicago first. I'm just going to go Denver. Atlanta, Denver, Buffalo, Chicago, Atlanta. We've used this same example several times. 743, which actually is the cheapest. This doesn't always give you the cheapest, but it does this time. Okay, let's go to the next one, in which they actually give you the table and not the graph, which is a personal preference of mine. I like it better that way. So we're just going to go ahead and look through here, and we see B, D, A, and C. So A, B, C, D. Let's just go ahead and put A, B, C, D. I find it much easier to do it this way without all the stuff that's already in there. I just really like this better. So, and they already have them listed in order. So B, D is 4. There we go. Should I use it? Yes, I should use it. So there we go. We're using that one. Highlight it if you want to. I'm not. AD is 5. Oh, great. Yes. Okay, let's stop here. First of all, don't do AB. Like, AB is totally not going to be a thing. Because if you do AB, then you will be cutting yourself off from ever getting to C, right? So AB is out. So if you want to mark it out, you could. I'm going to address that in a minute. But here's what I really wanted to talk about, or what I really wanted to talk about. D has a degree of 2. You're never going to have a degree other than 2. You will never use D again. So let's mark out the rest of the D's. Okay, back to the chart. AB is 6. We just talked about this. Don't do that one. No, that one's just a no. Use it? Absolutely not. BC, I can do that. I can do that. Totally. And I do that, and when I do, that means that I have a degree of 2 on B. So I will never use another B again, but that's okay. There are no other B's to mark out. And it's really obvious how to finish this thing. At this point, you can look on the graph and say, oh, I better connect AC. But actually, that's the only option I have left anyway. So AC, there you go. Now, it does connect all four. It is a quadrilateral. There's a little overlap of the paths in the middle, but that's okay. So it's like A, D, B, C, A. And if you reverse it and go A, C, B, D, A, that's cool too. Final answer, you'll add those together. You'll add 4, 5, 7, and 9. You get 25. All right, we're going to do a few more examples in the next video.